Hello everyone. In this video, we are going to discuss about the topic gradient descent. Gradient descent is an optimization algorithm which is used to minimize the error functions in ML models. We minimize E, which starts from a random W, and at each step we are updating W in the opposite direction of the gradient. The main objective is to minimize the given function E of W, which represents the error. We use the gradient vector, which contains the partial derivatives of E with respect to the parameters. And we update the parameters iteratively based on the gradient. Gradient descent formula. Gradient descent updates the parameters W iteratively to minimize the error function E. This is done by computing the gradient vector, which consists of the partial derivatives of the error function with respect to each parameter. You could see the partial derivatives dou E by dou W1. So these are all the partial derivatives with respect to the parameters. The parameter update rule is this. Wi is calculated as Wi minus eta dou E by dou W, where eta represents the learning rate, which controls how much we adjust W in each step. And dou E by dou W is the gradient of the error function with respect to W, which determines the direction of change. Importance of learning rate. A small learning rate leads to slow convergence. A large learning rate may cause overshooting and divergence. Proper tuning is required for the optimal performance. There are different types of gradient descent. Batch gradient descent, it is using the entire dataset to compute the gradients. Stochastic gradient descent, it uses a single data point per iteration. Mini batch gradient descent, it uses a small subset, that is a batch of data. Applications of gradient descent. It is used in training ML models. It's also applied in DL for optimizing the complex models. Utilized in reinforcement learning and AI. Let us see an example of gradient descent. We shall consider a simple function E of W equal to W minus 3 square. Here the function has a minimum at W3 where E of W equal to 0. When we substitute W as 3, we get E value as 0. The gradient is computed as the derivative of the function. Here the function is W minus 3 square, so the derivative is 2 into W minus 3. This is the gradient which is telling us the direction and the rate of change of the function. The value of W gets updated as this W old value minus eta into the gradient. Let us consider the initial value as 10 and the learning rate eta as 0.1. And this is the table which is telling how far we start from the initial value 10 and we are in steps of different iterations we are reaching this minimum value. So in 0th iteration, the W value is 10, that's the starting point. The gradient is computed using the formula 2 into W minus 3, the value is 14. And the W value is updated using this formula here. So the old W value, the learning rate, this is the gradient, it's 8.6. So in the iteration 1, the W value is 8.6, we compute the gradient with this W. And we are updating the W value from 8.6, it becomes 7.48. In iteration 2, we shall see how far the 7.48 gets updated to 6.59. Finally, it goes on. And here we have shown the iterations till 5. And as we could see in this graph, we can see how far the value, it starts from 10, the initial value which starts from 10 and how far we go on, and we find the minimum value is reached at W is equal to 3. So here E of W becomes 0. So this is how the graph looks like. So in this session, we have seen the purpose of gradient descent and an example for that. Thank you.